Good afternoon from India, and I suppose we can start off with the class.
Good
Yeah,
afternoon, ma'am.
good afternoon, Vasant. How are you?
I'm doing great, ma'am. Thanks a lot. How are you?
I'm good.
Yeah. Sorry, you couldn't attend the class yesterday. We were
Yeah,
celebrating, yeah,
you were
festival
celebrating.
yesterday.
Yeah,
So
yeah. Which festival were you celebrating?
yeah, it's a Taipusam Kabaddi. It's a special festival for Kartikeya Swami.
All right. Okay.
Yeah.
So
So the day we
yes,
do Seva, we do prayers as well. So the day we got
yeah.
busy doing that
Today
thing.
it's a full moon today, and
Yeah.
yeah. So it is known as Maghi Purnima in India. I hope you have got
Mm-hmm.
Indian descendants.
Yeah, yeah. They
And
are from
that's
India. Yeah, my ancestors came from India.
okay. And how long have you people been there?
We uh We are the fourth, fifth generation.
Oh, so okay. Uh,
Yeah,
have you ever visited India?
yeah. I've been there in 2019 for a couple of
Oh,
weeks.
okay.
But yeah, that was for some shopping in Mumbai. That's it.
Okay,
Mm,
all right.
yeah.
You haven't been around.
No, my ancestors, if I'm not mistaken, they come from Bihar.
All right. Okay.
Yeah, yeah,
When does plantation workers?
yeah. It was when slavery was abolished.
Mm,
So the British needed people to work in the sugarcane fields. So
mm,
they went to India and brought my ancestors from there.
right. Yeah, because
Yeah,
most of our ancestors who have gone abroad at that point of time, they had gone to
yeah,
do labor, and then of course it
yeah.
opened up a lot of opportunities for
Hmm.
generations, for the next generations. It has opened up a lot of opportunities there.
Yes, ma'am. Yeah.
Yeah, right.
Right.
Okay, so I suppose we can start. Just give me a second.
Yeah, sure, ma'am.
So we'll start off with with the fourth block that we have in your syllabus, which is basically the correlation regression correlation regression, the forecasting part basically that we are talking about. Yesterday, I spoke to you about hypothesis, though I have not finished off the entire thing because it's not possible to finish off each topic completely because it takes a lot of time. Because if I continue with hypothesis today, then I won't be able to touch on this, and I wanted to touch a bit on this part as well. So that's the reason I'm going in with correlation regression, and this is what we will be studying today. And all right, so we are starting off with correlation regression. Now, if somebody who has done some uh, statistics are very familiar with these two topics, correlation and regression. And so what we'll be trying to do is understand the concept of correlation regression and the coefficients, how to calculate that. So the question that we are asking here is that are the variables related to each other, and is there a mathematical tool that can establish this relationship between these variables? So we talk about correlation, where which we say is basically it's an association. Not like it's not very necessary that it has to establish a relationship outright, but it tells you that yes, there is some sort of an association between the variables, and it is very, very necessary to understand that this association that we are talking about between the variables, it is something that is there from theory, the theoretical concept of the thing that you're studying. So that will tell you that is there an association between them or not. What correlation basically tells you, does for you, is that it will tell you the strength of the association which is there between these variables, and it will also tell you the direction of the association. So please understand that before you apply these tools like correlation and regression, you need to have a very thorough conceptual understanding of what you are doing. So if I say that is there an association between the time of the classes and the learning ability of the student. So yes, studies have shown that that's the reason that most of the schools that we see are in the morning, like they have got a morning session instead of having a night session. Like why don't you call your like why don't you we send our kids at say 4 o'clock in the evening, and let them have a class from 4 to 8 in the evening, or 4 to 9 in the evening. But why don't we have that? Because there are studies to prove that when there is sun out there, your learning abilities are more, and you are more open, you are more receptive to ideas and everything. So that's the reason that most of the schools are there. Now, so this is a conceptual background that we are talking about. So this has to be understood before you apply a concept like correlation or regression. So you can have again, mathematically, if you see, it can there can be an association, like you will have some value if I say that the number of horses in a country and the like the number of food stalls in the country. Now there can be like if you do that, you can have a association out there as well between the number of horses and the number of restaurants in a country. You can have a number for that. But does it make sense? No, it doesn't make sense. Like what are horses to go to do with the number of restaurants? So there's no association between that. So that's a reason we say that you have to talk about we need to understand the conceptual background before we apply any of these tools. So correlation will tell you about the strength of the association, and it will also tell you about the direction of the association. One more important thing before we move ahead is that correlation can never exceed plus minus one. So it's written here plus minus one. So that's the value of correlation, and it cannot go beyond that. So please remember that you can never ever have a value of your correlation which exceeds plus or minus one. And the symbol for correlation is R. R is the symbol that we use for correlation, and it has to be plus minus one, cannot be there, cannot be more than that. Regression, on the other hand, is a cause and effect. It shows the causality between the variables. So once you have done your association, so I say the time. If this is the example that I'm taking, if this is the example that I'm taking, so I will have an R, which, like, just again, presuming, say it comes out to be plus 0.95. It comes out to be 0.95. So now, once the correlation has been established, then we go for regression analysis, which will tell you about the causality. Basically, you have a dependent variable and an independent variable, and you see that how much is the other independent variables determining or influencing your dependent variable. So that is what a regression does for you. So the most common tool to calculate your correlation or to look at the association is your scatter plots. Basically, if you are, I suppose, let me just, how many you are well versed with um, uh, Excel? Okay, you cannot see my tab. Uh, my PPT is not visible. Okay. Uh,
Not now, ma'am.
it was earlier, it was visible.
Earlier it was, yeah.
I was just asking that how many of you are well versed with Excel, MS Excel, Microsoft Excel? Mm,
Yeah, can manage. Well best,
and
sort of, yeah.
sort of. Yeah, Farida, you use a lot of Excel? No. Okay, she's busy. She's got a meeting. I've uh, all right. Uh, Fine. Let me go back. So, like in Excel, like in we have uh, like in Excel, we have got a uh, option of like making graphs and bars and curves, and there we have got an option of making scatter plots. So this is what that is what a scatter plot does, and so that is the most easiest way of finding out the your correlation. So what we do is we just plot both the variables that we have, and so it can be, say, like for example, age and learning ability, if we are finding out an association between them. So we can plot age, and we can take learning ability, and we can put it in Excel, and it'll give us a scatter plot. And then you pass a trend line through that scatter plot. So that gives you the direction of the association, that whether it's positive or negative. So here is an example that I have done. Here is your the two uh, variables are promotions and sales. So these are the two variables that we have taken, and we have plotted the graph. And if you can just, if you look at this, the scatter here, you'll find that they are very closely knit, like they're all clustered together. They are at one, like they have all come together. So that means that there is a strong association, because the closer they are to each other, these values are to each other, that means the better the correlation is, or the higher the correlation coefficient is. And then what we do is we can pass, like, we can, from through here you can always pass a scatter plot. And if you sorry a trend line. So you can always pass a trend line, and this trend line, in this case, it's a positively sloped curve, so it's going upwards. So it's a positively sloped curve. So we say that here we'll say that the R is it's positive. So that is how you measure it, right? The next that we are talking about is, like, these are some examples that does smoking cigarettes increase systolic blood pressure, plotting number of cigarettes smoked per day against systolic blood pressures. And so you have that. So this is the data that we have taken. And uh, if I just yeah, somebody wants to say something. Go ahead. Somebody's wanting to say something, I suppose. No. Okay. Uh, this is the data here for us. So it's the countries that are there. You've got the cigarettes, you've got the chronic health disorder, heart disorder, like you have here, and these, like if you're smoking 11 cigarettes, it's as high. So you can see that. And what is has been done is these like these dots that you're seeing, or the bubbles that you're seeing, these are the actual values that are there. And from here it is coming out that they are not very close to each other. That means the association is not very strong. But when we pass the trend line, this red line is the trend line, and when we pass this trend line, we found that there is a positive relationship, there's a positive association, but it's not a very strong association, because if you can see that they are scattered. And plus there are few outliers here in the things as well. Outlier basically means a number which is like, which are the extreme values. It can be the extreme value at at the upper level, or it can be extreme value at the lower level. So we have got a few outliers, like this is an outlier here. These are outliers because they are lying very much away from this from your trend line. So these can be the outliers that are there. So this is the most commonly used tool. But please remember that this is applicable only if you have got a bivariate relationship. That means if you're looking at the relationship between only two variables, so then it is possible to have this scatter plot thing. Otherwise, like if you are having a multivariate um, uh, relationship that you're trying to look at, a multivariate basically means where you have got more than two number of variables. So when if you have got a large number of variables between which you are trying to look, you are trying to have an association, then you cannot have a scatter plot. Then you have to estimate it using the formulas. So now again we are talking about, oh, I've done a lot of scribbling which I have not removed. Just let me see if I've scribbled more. All right. So we are saying that there is a positive relationship between cigarette smoking and heart diseases. The relationship looks strong, not very strong, but okay, it might be strong because these dots here are quite close to the line. These ones are again very close to the line. So yeah, you can have a strong. Like we have not done it numerically. We are just trying to see it graphically. We are just trying to have a look at it. And of course, they are not online because you've got the outliers as well. Now, so this is the trend line, and this is a spurious relationship, like number of hours slept and number of monkeys on the street. So again, it can, like, graphically it can be there, but of course these are unrelated things, spurious relationship that we talk about. So why are we interested in knowing the relationship between the two variables? What will happen if the relationship is perfect, and what will happen if there is no relationship? So that means we are trying to say that why are we looking at this relationship between cigarettes and heart diseases? Is there a reason for finding out this relationship? What happens if the relationship is perfect? That means your heart disease is caused solely because of cigarettes. Then what happens? Cigarette smoking. And what happens if, data wise, there's no relationship which comes out between heart diseases and smoking? Now, I suppose all of you are are aware of the current news which is happening all around the world. Like if I continue with this same example, New Zealand has said that it will be stopping the sale of cigarettes for people below the age of 16 by 2025. I suppose that is what New Zealand has said. Uh, Vikas, you will be better off because you are close to New Zealand. So to let us know what is the year that they have said. Not Vikas, sorry. Uh, sorry. Vasant. Vasant, you are near to New Zealand, and so what is it? Like,
Uh, yes, and now we know that I think it's about six New Zealand. It's about 6, 7 hours flight. Yeah.
But still, you are much closer to them than we are.
Okay, then the rest of the okay, right, yes.
And because of that day you said that you people import milk from New Zealand, so I thought that
Oh,
okay,
right, okay,
right,
yeah,
yeah, that
yes, I
that was
do.
my reference point.
Mhm.
Yeah. Okay, now even if you don't know, like you can always, you people can Google it and see that New Zealand has said that it has declared that it will be stopping the sale of cigarettes to uh, kids till the age of 16, I suppose. That is what they have said. And
Mm.
that by 2024 or 2025, they'll be stopping that. So that means that they have done studies which show that smoking cigarettes causes a lot of health issues. So that's the reason that New Zealand is coming out with that policy, because in terms, like as an economist, we always talk about that. We say that okay, fine, it's good to ban alcohol, it's good to ban cigarettes, it's good to do a lot of these things, but then they are also revenue bringing stuff, so they bring in a lot of revenue for your country. So now how do you substitute that revenue? Yeah, so that those are questions of economics, of course, out of the realm of this topic that we are doing. But yeah, so and again, if there is no relationship between the two, if some country can prove that, or some companies can prove, like the companies constantly, if you look at the tobacco companies all over the world, they are they constantly try to manipulate the policy making by the governments, because obviously their sales will get a hit. And that's a very strong, the tobacco lobby in every country is a very, very strong lobby that you have got. So yeah, so now this is what we are talking about, the correlations. We say that it's a numerical summary measure that indicates the strength of linear relationship between pairs of variables. Now please understand that we are talking about, we are, the word that we are highlighting over here is a linear. Linear means a straight line relationship that we are talking about. That means we are talking about the change that is happening to be linear and not quadratic or cubic here. So we are just talking about a linear relationship, and it is a single number that summarizes the information that is there in the scatter plot. So it measures the strength of linear relationships only. So if you are having non-linear relationships, if those are there, if it's not a straight line relationship, then correlation is not the best way to do that. There are other measures to that. So what are the types of correlation that you have? You've got positive correlation, you've got negative correlation, and then you've got no correlation. So these are the three types of correlations that we have. Correlation coefficients, as I've said earlier, that it is always between 1 and -1. Like it will always vary between +1 and -1, and the sign will refer the direction, like the association, the direction of the association, that you can come to know from these signs that you have, the positive and the negative signs. So that means that if there is a positive sign coming in, that means both your variables, or all your variables, are positively related to each other. They are all going in the same direction. And if the sign comes out to be negative, so that means that there is an inverse relationship between them. So, and this is based on covariance. We'll come in a second, we'll come to what covariance is. So here the example that I have taken is that if your price goes up, your supply also goes up. So if the price of any product is going up, obviously the supply will go up. So like whether we are talking about cars, we are talking about SIM cards, we are talking about hotel rooms, the logic remains the same, is that if the prices are more, you sell more or you supply more. And if the prices are low, then like if in the second condition, we are saying that if the prices are high, the demand is low. So that means there is an inverse relationship between price and demand. If the prices of anything goes up, then the demand comes down. So that is how it works. So now here in this case, your R will be negative. In this case, your R will be positive. But it will always hover between -1 and +1. That is how it works. And now this is just I'm giving you 2 minutes to just look at this graph and just to understand it. So from this graph, it is clear, from this like picture, it is clear that we say that there can be, of course, we have got three things, positive, negative, and no correlation. So if you have got a zero correlation coming out, if your R is coming out to be zero, that means there is no relationship. And you can see from the graph here as well that there is no relationship. All the dots are scattered, like there's no symmetry in them. If you're talking about positive, we talk about how strong the association is. So if it comes out to be perfectly one or anything near to one, so like basically we say that if your R is coming out to be anything above 0.75, we say that it's a very strong relationship that you have. And if it is zero point 0.5, we say that it's not so strong. It's a positive relationship but not so strong. Same logic or same argument goes when the relationship becomes inverse. So you have got this perfect where they are all in straight line, and then you have got them a bit scattered over here. So yeah, so that is less than negative zero point 0.5 because it's an inverse thing that we are talking about. uh, mm, okay, so Farida, when you leave, just let me know. Means not leave. Basically, when your thing starts, just let me know so that I can make somebody else. Uh, Vasant,
Yes, ma'am.
I am adding you. Like you are speaking from your mobile or from your laptop.
It's from my mobile, ma'am.
Okay, so you are comfortable in your mobile or in your on your laptop.
The mobile is good. Yeah.
Okay, so I'm adding you as a co-host.
Right.
Okay, right. So you after because Farida is will be occupied somewhere, so then you can let people in, right?
Yes, no, ma'am. Okay. Yeah.
Okay. So yeah, any questions so far? Anything that you have not understood so far? Kindly let me know. Everything is clear. What we have spoken so far, what I have spoken so far. Okay, fine, cool. Uh, Now, this is covariance. Like a few slides back, I had said that correlation is something that is related, that is dependent on covariance. And what is covariance? Basically, you you have found out a central value. Like you find out a central value, which is basically your mean, and which is shown by your x bar, y bar, or like this bars is your mean. And you are then finding out, like if you look at here, you're finding out x minus x bar. So basically this is the deviation from the mean. And similarly you have got y minus y bar, which is for the y variable. So this is for the x variable and this is for the y variable. Now what covariance is doing is that it is finding out the the covariance. It tells you the average of the so we are saying we are talking about the average of the deviation from the mean of the two variables. So you can say, in other words, you can always say that it is the uh, mm, mm, why is the pen not working? Mm, Stop sharing. My PPT got stuck. These are the issues of technology. Okay, so we were here. We were here. All right. So I was just telling you people that I had already written, but that has gone. So fine, you can say that covariance. So what have I written? That covariance is the mean of the product of the deviations of the two variables from their respective means. So because x minus x bar is basically nothing but your dx, which is your deviation from x bar, and similarly same is for y bar, which is dy, which is your deviation from y bar. So what are you doing? You are multiplying the two. You are multiplying the two, and by multiplying, you multiply and then you are dividing it by n. So when you're dividing it by n, what are you doing? You are basically finding out the average of the product of the deviations. This is what you are doing. So this is what a covariance is. Now the question is that why covariance is needed in correlation? Because we want to find out the relationship of the association that is happening. So we are interested in wanting to know the dispersion as well. So from the dispersion comes your correlation. So that's the reason that we need that. So this is the Carl-Pearson coefficient of correlation. This is the formula for estimating the correlation by using the Carl-Pearson's uh, product moment method, which like it is also known as the product moment method or the Carl-Pearson method, and this is the most commonly used like formula for estimating correlation, and it has got a lot of other variations. Like there are a lot of variations to this formula. Different people do it differently, because like I can write this the same thing as summation x minus x bar times y minus y bar upon sx sy. So basically this is nothing but your covariance, and these are standard deviation of x, and like s stands for standard deviation. Okay. So we are saying that correlation is basically your standardized covariance. You're standardizing your covariance. That's the reason that covariance is required for your correlation. Now, Okay. This is the numerical that is there for you. So this is an example that we have. So these are the values that you've got 2, 4, 6, 8, 10, and you have got 10, 12, 18, 20, 30. So what is the first step that you do is you estimate the mean. So for finding out the mean, what we have done is nothing but 30 divided by the number of observations, which is 5, which comes out to be 6. So mean of x is 6. Similarly, we found out the sum of y, which is this is summation y, and this is summation x. So again, you divide 90 by 5. So if you want y bar, so you do what? You divide 90 by 5. So you get 45 over here. And sorry, you won't get 45. You'll get 18 over here. You'll get 18. And so this is your mean. Then what we do is we find out the difference between each, like we find out the deviation of each variable or each observation, not the variable, sorry, wrong word, wrong term. We find out the difference of each observation of the variable from the mean. So it's 2 minus 6, 4 minus 6, 6 minus 6, 8 minus 6, 10 minus 6. Then we squared it up to get the standard deviation. Similarly, we did it for y, and we again got the standard deviation of y. So standard deviation of x comes out to be 2.8, and standard deviation of y comes out to be 7.04. Now, one step is required because our formula is covariance divided by standard deviation of xy. Covariance xy divided by standard deviation of x and y. So what we do is, what we did is, this is the deviations that we got from here, and these are the deviations that we got here. And now we are finding out the product of these x minus x bar and y minus y bar. So we calculate, we multiply all of them, and then we get the summation as 96. What is covariance? Covariance is what? Covariance is basically summation x minus x bar y minus y bar upon n. Now here what I have done is I have done n minus 1. Why have I done n minus 1? This is your basically degrees of freedom. This is basically because we are doing for the sample. So we are taking n minus 1, otherwise you straight away take it from n, and your covariance comes out to be 24. Your standard deviation was how much? Your standard deviation of x was 2.8. The standard deviation of y was 7.04. Your
Excuse
covariance
me,
came out.
ma'am.
Yes.
I think that the screen is not showing anything.
Since when is it not showing anything?
Yeah.
Uh, since when was it not showing anything?
It's been a good 2 minutes, I think.
So you people did not see any of the calculations?
No, no, just few minutes.
Oh, 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 oh. Uh, all right. Okay. Uh, mm. Okay, so what we are doing here is we were here when I had stopped it, I suppose. Uh, covariance
Yes,
is clear.
ma'am.
Yeah, this is clear to everybody, I suppose. The covariance is clear. What is covariance? Is it clear, or you want a more clarification? Do you
It's
want
okay. It's clear for
it?
me, ma'am. Thanks.
Yeah, it's okay. All right. So what we are doing here is we found out covariance, and now this is a numerical that I was trying to solve. This is your formula for correlation. Covariance xy divided by x sx sy. S is standard deviation. S stands for standard deviation, and we said that correlation is a standardized covariance. So what you do here, you have got your numbers 2, 4, 6, 8, 10. Similarly, for y, you have got 10, 12, 18, 20, 30. So what we did first is we found out the total of our x, which comes out to be 30. And then we estimated the mean, which is summation x upon n, 30 divided by 5. So you got 6. Similarly, if we found the total of y, which came out to be 90, and then we divided 90 by 5, we got 18. So your y bar becomes 18. So then we found out the difference of each of these values of these observations from the mean. So it's because the mean of x is 6, so it's 2 minus 6, 4 minus 6, 6 minus 6, 8 minus 6, 10 minus 6. And you have the total, and then you have squared it up. Why did we square up? Because we want to find out the standard deviation, and the standard deviation formula is this: summation d square upon n, the whole under root. So the total came out to be 40. 40 divided by 5, the whole under root, so which came out to be 2.8. The same procedure we adopted for y. So this is 10 minus 18, 12 minus 18, 18 minus 18, 20 minus 18, 13 minus 18. We squared it up, got 248. From here, we calculated the standard deviation. We got 7.04. So that means our denominators for this formula, we have the denominators ready. For this formula, we have our denominators ready. Now we need the numerator, which is basically the covariance. So for finding out the covariance, what we did is we had our x minus x bar and we had y minus y bar. We took the product of it, we multiplied the two, and this is how we multiplied, and the total came out to be 96. Because this is from the sample, so here the formula that we are taking here is covariance is equal to summation x minus x bar times y minus y bar upon n minus y, because this is for the sample that we are talking about. Or you can straight away take, if you consider this as a population, then you say that covariance is equal to summation x minus x bar times y minus y bar upon n. So this is also right, this is also right. This is in case of a sample that we're taking. So 96 upon 5 minus 1, this comes out to be 24. So this becomes your, this is your numerator that you have for the formula, and the denominators we calculated earlier. So it's 24 divided by 2.8 and 7.04. So this comes out to be like if I just, let me again do it. So my R is equal to, so covariance came out to be 24 divided by, so if I just, this comes out to be 1.42. Now this is because this was a, This is an hypothetical example. So this our value is coming out to be 1.42, which is not actually possible. Like if it would have been a real case, then we would have said that there was some mistake in our calculation. But because this is a hypothetical example, just taken out of the mind, like we just took some numbers and we found out, but the procedure remains the same. The procedure remains the same for calculating it. Okay. So let's do like here we have another example where the covariance is already calculated for us. The covariance is 15.5. Standard deviation of X is 2.33. Standard deviation of Y is 6.69. So in this case, you have the covariance, which is 15.5 divided by 2.33 times 6.69. So this comes out to be 0.99. Now, the interpretation is that this is a very high degree of positive correlation because it's a positive that you are getting. It's in the positive, and it's a very high degree of positive correlation because it is almost near to 1. Your correlation is coming near to 1, right? So is it clear? Is it clear so far? Any doubts so far?
Okay, ma'am. Thank you.
Anybody who's not clear with the solving part that we solved? Anybody who has got any issues there? Kindly let me know. Isa, how are you?
Good morning, ma'am. Okay,
Morning. How are you?
I'm fine. And you?
And you're I'm good. You're following what is being taught in the class?
Yes, yes.
Okay. Osman?
Thank you,
Ah,
ma'am.
yeah, thank you so much,
Uh,
Isa. Yeah,
Good
Osman.
afternoon. Good afternoon, ma'am.
Good afternoon. Good afternoon. How has it been so far? Are you following what is being taught in the class?
Yes, ma'am.
Okay, no issues.
No issues. I
I'm a great
understood.
teacher. Yeah, I'm a great teacher. Uh, everybody is
Of course,
understanding
yes, of
everything.
course. Yeah.
Of course, yeah, because everybody's understanding everything. So I am presuming that I'm a fantastic teacher. Okay, let me be in that thought. Uh, okay. Now, this is another way of finding it out. It's the same thing. Like if you go through your textbooks or the material that has been provided to you by IGNOU, you'll find that this is another way of doing it. What basically happens is that if you're going with an assumed mean method, like you're taking an assumed mean, that means instead of this saves us a lot of time basically, that because we are just assuming, like instead of doing summation x by n, what we do is we are just assuming it. Now some this is again some, like you can use this formula as well, like absolutely fine. This formula is, but the formula changes for correlation, and uh, instead of remembering so many formulas, I always tell my students that you just understand the basic concept and you do it. You When you're practicing your numericals, practice it by two methods preferably, so that you understand what the difference is, and you get your answers right. Now here we have got uh, an example of multiple correlation. Now, multiple correlation means where you are having more than two variables, and you are then calculating uh, you're finding out the association or the correlation between them. Here you've got three variables: machine hours, production runs, overhead. And then if you're doing it, then it becomes multiple correlation. We can also do bivariate, like if we just want to take two of them, and we can do that as well. So here, this is like I have just done it in a short way. I've done it, and this is the direct method we are doing it, and you get your R, and then this is how you do it. You want, you can do it. Otherwise, there's no relation. Now, after you find out your R, you have got something called your R square, which is basically the coefficient of determination. What R square does is that it tells you what is the goodness of fit of the model. That again, not very required for you people. Mm, okay. Now, after like so far that we were talking about quantitative data, or data in the interval scale or ratio scale. Like the data is given to us in the ratio scale, and you are finding out the association between them. So you use the Karl Pearson's coefficient of correlation. Now, supposingly, I have got variables which are not numeric in nature, but which are attributes, which are qualities, basically, which are like qualitative things. And you have your data either in the nominal scale, or you have got it in the ordinal scale. Now, how do you go about this? Like, how do you go about now finding out your correlation? So, like here, I have taken if I want to find out the correlation between gender and skin color. Now, you people come from a country, from a continent where you people have faced a lot because of the skin color. Like till date, you are facing that sort of a uh, what you are facing a sort of discrimination based on your skin color. And like I also come from a country where the skin color is very, very important. So if you're fair, you are good to go. If you're not fair, then it becomes an issue. So now we, and plus if you're a female, like it's a double whammy. If you're not white, or a wheatish in complexion, and you are a, why is my video off? There's something going on with my Google Meet today. Okay, because all right, my background. Okay, everything got screwed up like that. Fine, I got it now. What the problem was? Okay, so now if I say that. Uh, Okay, I'm talking about female, which is again, like gender is again an attribute, and we are talking about um, uh, we are talking about skin color. And so we are talking about the skin color, and we are talking about uh, uh, the gender. So that becomes a very interesting study, because uh, it like somewhere it uh, uh, what should I be saying, that these studies are important to be done. Just in a small statement, if I want to say that, so I just say that it's very, very important for us to understand these relationships. So now what I do, instead of using my Karl Pearson's coefficient of correlation, I will use other methods of correlation, which is basically there's something called rank correlation. This was given by Spearman rank. Okay, so here your formula becomes 1 minus 6 summation. This is 6, huh? 6 summation d square upon n cube minus n. So this is how you do your this thing. You calculate, estimate. I'll just give me a second so that we can do very quickly, we can do a small numerical on rank correlation. And I should have taken it out earlier, but me being me. Mm. Okay. Now, mm, there's somebody who's wanting to get in, and fine. Let me. Vasant, you now have to like give admission to people.
Yes, man. Just admitted one. Yeah.
Yeah. Okay. Why is the screen not sharing? A window. Yes, a window, and here is correlation regression, and here is the PPT. And okay, it's starting. All right. Now, if you just go through this problem, it says that an office has 12 clerks. The long serving clerks feel that they should have a seniority increment based on length of service built into their salary structure. An assessment of their efficiency by the departmental manager and the personal department produces a ranking of efficiency. This is shown below together with a ranking of their length of service. Now, they have given you two ranks. One is the rank of the length of the service, and the other is the rank of their efficiency. Now, where I wrote this formula, I have missed out one thing. Now, what does D stand here for? D is equal to Rx minus Ry. Rx is rank of X, and Ry is rank of Y. So basically what we do is that whenever the variables are given to us, you need to rank them. So if you have got the variables, so rank the observations of a variable either in increasing order or decreasing order. So either you do it in the increasing order or you go by the decreasing order and you do that. So you have got the ranking here. You have got the two ranks. This is Rx and this is Ry. So what we now need to do is we want to find out our D, which is what is D? This is the difference in the rank. So if I so it's 1 minus 2 minus 1, 2 minus 3 again minus 1, 3 minus 5 minus 2, 4 minus 1 3, 5 minus 9 minus 4, 6 minus 10 minus 4, 7 minus 11 minus 4, 8 minus 12 minus 4, 9 minus 8 1, 10 minus 7 3, 11 minus 6 5, 12 minus 4 8. This step is clear to everybody. What I did, I found out the difference in the rank. Is this step clear to everybody? Just somebody put on your mic and let me know if it is clear or not.
It is
It's
clear.
clear.
Okay, thank you. So the next step is you do your D square. You find out the square of these deviations. So that stands out to be 1, 1, 4, 9, 16, 16, 16, 16, 1, 9, 2564. You then find out the sum of this. You find out the total of this. So this comes out to be what? 45669 is 15 plus 16 is how much? 15 plus 16 is 31. Plus 16 is 47. Plus 16 is 63. Plus 16 is 79, 80, 89. 89 plus 20 is 109, plus 5 makes it 114. 114 plus 60 is 174, 178. Is it coming out to be 178? Somebody please do it very quickly on your calculators and let me know. Is it coming out to be 178? No, it's coming out to be 189 or 178. Somebody please do it on your calculators and let me know how much is it coming out to be, the total.
$187.
Oh, it's coming out to be 187. Okay. All right. So let me make it 187.
And D2. How do you get this
The
D2?
square. I just squared. It's not D2, it's D square.
Okay.
It's D square. It's
That's
not D2. I've not written, yeah, it's yeah, D square. So I just squared it up.
okay. I get it.
Yeah. It for everybody it is coming out to be 187. I need to come out and see.
Yes, 187.
Okay, all right. Farida is back.
Yes, ma'am, 187.
Okay, 187. So now what we do is we have got our R, which is 1 minus 6 summation d square upon n cube minus n. Now this is 1 minus 6 times 187 upon n is the number of observations, which is 12, I suppose. 1, 2, 3, 4. Yeah, so this is 12, your number of observations. So it's 12 cube minus 12. So if I now solve it, it comes out to be 187. 187 into 6, which is 1122 divided by 144 into 12 is 1728. 1728 minus 12. So my correlation is coming out to be 0.35. Any issues with the estimation, with the calculation part? Does anybody has any issues? I'll then come to the interpretation part.
That's okay, ma'am.
Okay, all right. Now comes the interpretation. Now the question is that these clerks are asking that they should be getting an increment according to the seniority. So what the company did is the company ranked their efficiency and their seniority. Correlation is coming out to be 0.35. Should the company listen to their demands?
Yes, ma'am.
Okay. Vasant says yes. What does other people what do the other people say? What do other people say? They are asking for their what they are asking for their increment on the basis of their experience, and the correlation between experience and efficiency is coming out to be 0.35. Is the correlation coefficient high? Is it good or bad? Is it poor association or good association?
What's
Mm.
what's the value of the coefficient again?
Yeah, the value of coefficient is 0.35. Is it a strong, is it showing a strong association between the two variables, or is it showing a poor association between the two variables?
There's a poor association. It's way below 1. So
Yeah, way below 1. So should the management listen to these people?
no, there's no association between the
No,
experience
no.
and the efficiency.
No. Yes. So Vasant was talking from his experience. He was talking about his company, his school, I suppose. Uh, is that so, Vasant? Uh,
Uh,
so
no, I thought because it was positive 0.35, that's
no,
what I
no,
thought.
no, no. Positive. Look, positive means okay. Let us look at the interpretation now.
Mhm.
When we talk about the interpretation, now R is equal to 0.35. So that means there is positive association between experience and efficiency, but the coefficient is below 0.5. Therefore, there is poor positive association. The company should not listen to the clerks,
Right, ma'am.
right? So that is how you do it in your companies. When you people will be doing it, you can do it most of the time, like I think so. People who are dealing with sales figures and dealing with production, with output, there you are using your Carl Pearson's coefficient of correlation. There you are using this. Okay, you are using this Carl Pearson's coefficient of correlation. But yes, when you if you are talking in terms of HR, like the human resource department in your company is there, or there are you want to find out customer behavior, like you are doing some behavioral studies where you are wanting to where you are asking them some questions on attributes, and when you have got the data in the nominal scale or the ordinal scale, then you go for the rank correlation. So that is how you do it. So this is about your correlation. We are not going into the testing of correlation, like we are just talking about the factors which affect your correlation. That can be uh, range restrictions are there. You have got non-linearity. So if it's as like in the beginning when we started, we said that correlation looks at linear relationships. So if there is a non-linearity, then you do not go for correlation. There are other methods of doing that, and we won't go into the testing of R. Let's come to regression now. Regression, I started off saying that it is a causality. Tells you about the relationship, like the degree of association you found out through correlation. But is there a causal effect? Is there a cause and effect relationship between the variables that you come to know from regression? Now, basically, regression is a tool for forecasting. Please remember that this is a tool that you use for forecasting, and it is a tool to find the determinants of the dependent factor. So whenever you're talking about your regression, you always talk in terms of dependent variables and independent variables, explanatory variables and explained variables. Like there are different terms for it. The nomenclature changes, but the thing remains the same, that you have got a dependent variable and you've got an independent variable. So here, if I say that sales is a function of price, so that means I say that sales depends on price. Your price is it the other way around? Price depends on sales depends on price. What is it? People from the market? Sales depends on price or price depends on sales?
Company sales are affected by the price.
Yeah, so sales is a dependent variable. So sales is a function of price. So sales is the dependent variable and price is the independent variable. So now we want to see that, say supposingly one of your managers comes out and he says that we need to have a relook at the price because it is affecting our sales. And you feel that no, it's just not the price which is affecting the sales. There are other factors as well which are affecting the sales. It can be the state of the economy. It can be your product line that you have. It could be the competitors who are there in the market. So it can be other things which are affecting the sales of your product. So then you say that, okay, let me do a regression. Let me carry out a bivariate regression and let me see that how much of the sales is getting affected by price. And can I do a forecasting for this? So yes, you can do that. So you've got linear regression, and you people are studying, like for you, we are doing the most basic regression format. So we are not going into the logit model, probit model. We are not going into that. We are just talking about the OLS. We'll be talking about ordinary least square. So we are saying that a technique is we use to predict the most likely score of one variable from those of the other variable. And so this is about prediction that we are talking about. So we say that the assumptions are that there has to be a normalcy of the data. So you say that your mean is equal to median is equal to mode, because this is x, like you're talking about x bar is equal to m is equal to z, which is mean is equal to median is equal to mode. And this is how you check your normalcy. And you then look at the min and the max values, and then you're saying that there has to be a linear relationship. That means a straight line relationship. So the rate of change is constant. Whenever you talk about of linear relationship, that means that the rate of change is constant. And you are saying that the dependent variable is quantitative and continuous. That means if your dependent variable is qualitative, also you can do regression. It's nothing that you can't do a regression, but then the model that you follow is a different model. If your dependent variable is an attribute, or it's a qualitative variable, then we use other models for it. The logistic models, we go for that. Otherwise, we for the normal ones, we assume that it is quantitative and continuous. That means it's on the ratio scale. Now, these are the components of linear regression. You have got y and you have got x. So y is the variables you are predicting. That is the dependent variable. So it is called the predicted variable. So y is your dependent variable, x is the independent variable. Then you have got something called y hat, which is your predictions, the forecasting that you have done. And in many books, you'll find it written as y dash. Generally, we use y hat. here, or y cap, whichever way you are saying. And this is your regression equation. Y hat is equal to a plus bx plus e. In certain books, you'll find it written as y is equal to alpha plus beta x plus e. In some books, you'll find it written as y is equal to beta naught plus beta 1 x plus e. Comes out to be the same thing. It is a plus bx plus e. Now, what is e? E is the error term, or the noise in your model. And how do you estimate it? You find out the difference between your actual value and your predicted value. So that is your error term, that how much is the difference between my actual, what I have, what is there, and what I predicted. So my actual sales minus my predicted sales. So that is your error term. Obviously, you would want your error term to be as small as possible. That means you want your prediction to be as accurate as it can be. Now, what is A? What is B? A and B are two constants in your equation. A is the intercept, B is the slope of the regression line. And E, as we have said, is the error term. It's not y minus y hat, it's y hat minus y. It comes out to be the same. And it has to be very, very small. So if I just go back. Am I rushing today? Yes, I am rushing a bit. Is it clear what I'm talking? Like, are things making some sense? I know it's a Sunday. You people have got a class in the evening as well.
Yes.
Yes, ma'am, we have.
Okay. Hi, Grace is back. Okay.
Sorry.
Grace, I was
How are
missing
you,
you.
ma'am? Just internet connectivity
Yeah, no,
issues. I had
no.
to change my sitting arrangement.
Yeah, I also had to change my sitting arrangements, and that's the reason you can see the backdrop of my room
Yeah.
here, because for me also things were not working today. There was no electricity, so yeah, things were not working very well. But okay, okay, Vasant, you said that it's making sense. You have been there since the starting of the class, and okay, let me go back. And these are things which you people might be using a lot in your organizations. Either knowingly or unknowingly, you are doing a lot, or the data analysts that you have in your companies, they are doing it for you. But regression is a very, very common forecasting tool that we use a lot. All right, so let me come back. Always keep your dependent variable on the y-axis and your independent variable on the x-axis. So this is my regression line or the trend line. This point is my A, which is my intercept. This, like if I'm moving from point M to point N, that means there's a change. So this So this movement that we are having from point M to point N, this is basically the slope. So it's like basic the first order differentiation, del x by del y that you do, or dx by dy. So that is the slope of the regression line. So this is B, this is the intercept. That means the starting point from where you are starting off. How do you measure like why we are doing it? So this is just an conceptual understanding there, that we may want to make a prediction. We want to understand the relationship, that how fast does CHD mortality rise with 1 unit increase in smoking. So we are talking about like if somebody is smoking, then how fatal is it? So we are repeating the same data that we had taken earlier, and now we want to do a prediction model on this. We are trying to run a regression on this, and this is the regression line that you have, that we predict a CHD rate of about 14. For whom? For people who are smoking 6 cigarettes a day. This is this is basically, it's talking about somebody who is smoking 6 cigarettes a day. The mortality is, the CHD rate, the chronic heart disease rate is about 14. And that, from where did you come to know? You came to know because you ran a regression model on it. Now, how do you calculate this? Basically, how do you calculate this? So you have uh, okay. So you have these 3 ways of finding out your slope, or to measure your B. There are these 3 methods. One is you take covariance of xy and divided by the variance of independent variable. You have taken the covariance of xy. We have already learned how to find out the covariance of xy, which was, I told you earlier, it is the average of the product of the deviations taken from respective means. So that is what covariance is. So you take covariance and you are dividing it by the variance of x. X is independent variable. So you are dividing it by the variance of your independent variable. Variance is equal to standard deviation square. Okay, that is what variance is. You can also find it out if you have your correlation coefficient with you. So you can find it out by Sy upon Sx. This will also give you a beta value. Sy is what? Standard deviation of y, standard deviation of the dependent variable divided by the standard deviation of the independent variable. Or you have this entire big way where you are finding out your like very similar to the correlation equation that we saw earlier. So this is n summation xy minus summation xy summation x summation y time divided by n summation x square minus summation. So you are keeping your independent variable at the in the denominator, and you are doing it. How do you find out your intercept? Mean of the dependent variable minus b x bar. So you have to first calculate your b from here, and you can do it. Now, if I can go back to that numerical, I suppose we did the same here, like okay, but the correlation was not right. Okay, so here your covariance has been given. Covariance is 11.12. Standard deviation of x is 2.33. You find out the variance, so you just square it up. So which comes out to be 5.447. So your beta value is what? Because this was the first formula that we saw. Covariance of xy divided by the variance of the independent variable. So the variance of the independent variable is 5.447. The covariance is 11.12. So your beta value comes out to be 2.042. This is, then you find out your A. Your Y bar is 14.524. This is the beta that you just calculated, and you multiply it by your x bar, which is mean of the independent variable, and this is the A value, intercept value you get. Now, how do you write? Because this is the regression equation. So how do you write it? 2 plus 32 plus 2.042x plus E. Now that means that a change of 2.042 So we are saying that this is your prediction model. So that means if you change your independent variable by this much amount, okay, this thing went off. So we are saying that like 2.04 unit change in X is bringing about 1 unit change in your Y. So say supposingly you say that sales is a function of price. So that means if you change 2 units of your price, like you're changing your price by 2 units, your or like doubling it or like twice you're going it, so that will bring about 1 unit increase in your sales. So that is the prediction model, and that is how we use our regression for predictions. Any doubt so far? Anything that you have not understood, the calculation part, the conceptual part, anything, please let me know. Yes. Anything that you have not understood?
Is this something that we'll find in our material?
Yes, you should be finding it out. You have received the material?
Yes. Yeah.
Block 4. You need to open block 4, and these are the topics from block 4.
Thank you, ma'am.
Okay. Okay. There are n number of permutation combinations going on for regression. Like regression is one of the most dynamic models right now, and we have got so many variations of regression coming out. This is the most basic elementary thing that we have done. Okay, so now we are saying that once you know the relationship, we can predict. So you have got y hat bx plus a is equal to 2042x plus 2.367. So if you know the value of your x, you can always, like, x is what? Your independent variable. So that means the number of cigarettes that you're smoking. Like, we are going back to the same example, because this is from there we are talking. So we say that if somebody is smoking 10 cigarettes a day, the rate of change is 2.042, and your intercept is that means the number of cigarettes from where. Okay, let me go a bit into detailing here. This is the diagram that I made. Now, we say that chronic heart disease is a function of smoking. So that means you have got smoking here in the x-axis, and you have got your chronic heart disease here. If you are saying that your intercept is 2.367, that means your heart diseases starts for people who are smoking 2.36 cigarettes a day. That means obviously nobody smokes cigarettes in fractions. So if you are smoking more than 2 cigarettes a day, your probability of getting a heart disease increases. So that is what the intercept is telling you. Now your slope is 2.042, that is your slope. So now you are saying that if you multiply it with 10 cigarettes, that means somebody who's smoking 10 cigarettes a day. So then the disease increases by this amount, 22.787. So we said that 22.77 people out of 10,000 in a country with an average of 10 cigarettes a day will die of chronic heart disease. Is the interpretation clear? Is the interpretation clear? Like how we are using the model? Is the interpretation clear?
Yes, ma'am.
Okay, Usman, thank you. So, Usman, in your country, is smoking a problem?
Yes, ma'am.
In your country, is smoking an issue? Like, is it leading to a lot of heart diseases, or is it less? Is smoking less in your country?
Yes, ma'am. It's our country. Smoking is less, but
Okay,
there is
but
some drugs abuse. It's
okay,
more.
drug abuses. Okay.
Yeah, than cigarette.
Okay, all right. Like in my country, smoking is an issue. Like there are large number of people who are smoking. So yeah,
Yes, we
smoking is
are
an issue
seen in the film.
in the films. Okay, okay. You have watched Indian movies?
Yes, ma'am.
Okay, great. Good to know that our movies are popular in your country. You people are watching our movies.
Yes, a lot.
Uh, Okay. Yeah. So yes, smoking is very, very common in our country, and it does causes issues. So that's the reason that these type of studies matter for countries. Uh, mm. So if we are saying that Indian smokers are smoking 6 cigarettes a day, so 14.61 people will die out of 1,000 people every year. So actually we have got 23 deaths. So we predicted 14.61 deaths and out of 10,000, and actual number is 23 deaths. So the residual is 8.38, which is a very large error. So that means the prediction was not very good, the prediction that we did, because and there can be n number of reasons for those your prediction not coming right. It can be the data availability is not very good, or the data quality is not very good. That means the data that you collected is not of very, very good quality, or you can the data is not sufficient, like you took a very small sample and you did your prediction. So there can be a lot of reasons there for that. Okay, so this is the residual is basically the difference between each observation that you are having. So these red points are each observation. So the difference from the uh, your regression line, this is the line of good fit or best fit, and or the trend line. So the difference from this trend line to each observation is basically your error thing. So if it is coming out to be 8.38, that's a huge error that is coming out to be. And okay, so these are the residuals. Now, standard error, we won't come into these things because that's not required. So we are done with correlation and regression. And I wanted to keep like today, because this is the last session that you are having with me. So I wanted, I wanted half an hour for this session, but I still have around about 15 minutes. So now these 15 minutes are open. You can ask me anything you want from statistics, anywhere, whatever you have read, come out with your issues. This is just a 15 minutes of question and answer session that I've kept. I wanted it to be half an hour, but Yeah, sorry, it went longer than I thought. Please come out with your questions of all the things that we have studied in the past 4 days, or anything that you have read from statistics. Please ask.
Um, I wanted some help again. I know
Mm.
we discussed this yesterday,
Mm.
but are you in a position to just go through
Hypothesis.
yes, the hypothesis? How did you know? The null hypothesis and the alternative. The
Okay.
error 1, the error 2. When I sat alone to go through yesterday,
You
I could
struggled.
start again. Yes, ma'am.
Okay.
I seemingly I had understood, but then I think I missed it again somewhere.
Okay. 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 Let us take a fresh example today. Mm, uh, Grace, you have to now put on your mic because I'll be talking to you exclusively, so that everybody, it's easy for everybody to understand as well. Grace, when you are doing a study, you want to find out you said that day that people from the plan that people buy the most is 2 kwacha to 5 kwacha, the most. So when you want to launch anything new in your market, do you go with the assumption that if I do it for these customers, my product will be a hit?
Yes.
Okay. Now, this assumption that you're making is an alternative assumption that you're making. So you say that if I introduce anything for these people, for people with 2 to 5 kwacha, they will be best served. The null hypothesis tells us that no, there is the amount of recharge has got no impact on a new scheme. That is your null hypothesis. The alternative hypothesis is that the amount of recharge has an impact on any new scheme that the company launches. Are these two assumptions clear to you?
Okay. Yeah, I think they are. So the null is the negative. Can we say it's the negative?
The null hypothesis is the negative statement that I said, that there is no impact of your
Yes.
recharge value on the new product that you're launching.
Okay, so then we can always say that the null is always in the negative. Is that
Yes,
correct?
yes, yes,
Okay.
yes, yes.
Okay.
It is. It is always a negative statement. It is always a status quo. Means it says that there is no change. There is going to be no impact, no change. All right.
Or the null change.
Now,
I'm sorry, ma. Or to say the null change is always against the alternative.
no, it is you, Isa, you always frame your null hypothesis first and then you go with the alternative hypothesis. So you can say that your alternative is an opposite to null, but you cannot say that the null is opposite to alternative, because you start with your null hypothesis and not with the alternative hypothesis.
Okay, ma'am. Okay.
Right.
Thank you.
So yeah. So any no change statement is always a null hypothesis statement. That IGNOU has organized lectures so that it will help you in studying your subject. The null hypothesis is that the IGNOU lectures have no impact on the learning ability of the students. That is your null hypothesis. The alternative hypothesis will be that the learning ability of IGNOU students change with the classes, when the classes are held. So that is an alternative hypothesis. Now, what is your type 1 error? Type 1 error is that your null hypothesis is true. That means you should be accepting your null hypothesis, but mistakenly you reject the null hypothesis. Now, when does it happen? Like in most, like 99% cases, you are there, you are trying to prove your alternative hypothesis and you're trying to reject the null hypothesis. That means you want to accept your alternative hypothesis and you want to reject the null hypothesis in 99% of the cases. There are certain studies where you want to show that this does not have an impact. Like yesterday, I took the example of religion on intelligence. Say, supposingly, we see a lot of apartheid happening in America. We see a lot of crimes which are based on skin color. Now, if American agencies or the government of America wants to do a study, it will say that the skin color has got no impact on the crimes in the country. That is what their null hypothesis is. And the alternative will be obviously that the skin color has an impact on that. Now, supposingly your study proves that if you took the data of the crimes in America and then you saw that who has committed the crimes, like, is it only the people of color who have committed the crimes, or is it the white people who have committed the crimes? And like, when you went through the data, you found out that no, there is no correlation between the color of the skin and the crimes that have been committed. So it's committing crime is a very individual thing, and the color has got nothing to do with it. So in this case, you should have been accepting the null hypothesis, right? In this case, you should accept the null hypothesis. But you mistakenly, like your data, say supposingly the Republicans of America carried out this study. Obviously, they would want to show that the people of color have committed the crime. So they took a data from that area which is dominated by people of color, and they just took the crime data of that area. Obviously, people, if say supposingly Indians are living in that area, who will be committing the crimes? It will be the Indians who will be committing the crimes. So you can easily say that the people of color have committed the crimes. But so in this case, you should have rejected the null hypothesis, you should have accepted the null hypothesis, but you rejected the null hypothesis. So then you are committing a type 1 error. I don't know, Grace, whether I have confused you more or have I made things clearer for you.
Yeah, I was writing, so yes, I'm putting
Okay.
the puzzle where I was getting it all wrong.
Yeah. So if you are rejecting the null hypothesis when it is true, you commit a type 1 error. If the type 2 error is when you should have rejected a false null hypothesis, but you accepted it, then that is type 2 error. So out of these two errors, type 1 error is always considered to be a grave mistake. Like it causes a lot of research issues as compared to your type 2 error. Grace, now tell me, where are you stuck? Like now in your notes and everything, what is clear and what is not still clear?
No, I think it was the definition and understanding with the type 1 error. When it's now, it is true and mistakenly rejected, then I'll
Yes.
know that's the type 1 error.
Yes.
Yeah.
Yes.
So having understood that, then I'll easily find a way to
Type 2
understand
errors.
type 2 error. Yes.
Right. Okay. All right. Any other questions? Any other questions? Please come out with your questions. We still have 8 minutes. Please come out with your questions.
So, ma'am,
Yes.
I'm trying to also understand. I'm sure I'm not the only one. When assessments, is it assignments or exams do come, what should we focus on? The formulas? What is it that we need to really look at?
Yeah, in statistics, you need to look at the formulas, the parts where you have got numerical questions. Please practice them.
All right.
Yeah, any other question? Please come out.
Sorry, I didn't
Yes.
get the answer you gave to Grace. My network just cut.
Regarding the evaluations?
No, the formulas or
Yeah,
the
yeah,
application.
yeah. In case of numerical papers, do practice a lot of numericals. do practice a lot of numericals. You can always ask Dr. Smriti more about it, because the assessments are all given in a centralized manner. So she will be in a better position to guide you on that. But yes, as far as I have seen the past assignments, they have got a lot of, and especially, and also in the end term, there are numericals. So in the parts where you have got those numericals, kindly practice those numericals and pay attention to the formulas as well.
Okay, thank you, Stoya.
Right. Any other questions? Any other questions? Please come out with your questions. Please come out with your questions. Okay. No questions? No questions to ask? Hmm. Okay, so if there are no questions to ask, we have covered, like I've tried to cover as much as I could in these 10 hours of things that we had, because mm,
There is no question, madam. I think everything
yeah.
is clear for me, even for other colleagues. I hope.
Okay, it's great if it's clear. So that's what I said. It was just about the directions that we could give you regarding that. And fine, so we'll stop our class here. And best wishes to all of you for your exams. Yesterday, I was told that I would be taking another subject for you people. I suppose